Following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. All right, so today we're going to start chapter 8. We're going to look at section 8.2, part 1. And so let's go ahead and start. I want to start out with an example where we have a bunch of people. So let's see, we'll put John and Maria, Sam and Ralph and Susie in there. And then over here, we're going to have birth dates. And let's see. John was born on June 4th. Maria was born on August 3rd. Sam was born on October 12th. Ralph was born on December 5th. And Susie was also born on October 12th. Now, Sam and Susie aren't twins. They don't even know each other, but they have the same birthday. So what I want to look at here is how people and their birthdays work, okay? Each person has exactly one birthday, discounting religious experiences, of course. But each person has exactly one birthday. You don't have one person with more than one birthday, but you can have more than one person having the same birthday. This is how something behaves that we call a function. I want to point out that function starts with the word fun and it ends with the word shun. So starts out fun and then you get shunned. I don't know. Anyway, enough of that. All right. Let me read to you out of the book. This says function. A function is a set of ordered pairs in which to each first component there corresponds exactly one second component. The set of the first components is called the domain of the function, and the set of the second components is called the range of the function. All right, so function. You've got the domain and the range. Another name for domain would be input or X value or first coordinate. First coordinate. I don't know if I spelled that correctly. And let's see, cause. Your range would be your output or your Y values or your second coordinate or the effect. Okay, so these are all different names for the same thing. Domain is all your inputs or your X values. The range is all your outputs or your Y values. Oh, also, this could be an independent variable and dependent variable. Okay. So we've got all these different names for the same thing. Basically, the domain is the input or the X. The range is the output or the Y values. Okay. And so for each input, there can only be one output. But you can have several inputs going to the same output. You just can't have one input going to several outputs. When you have that, it's not a function. All right, I want to look at some situations and then we'll talk about whether these situations describe a function or not. Okay. Let's see. We have this set of ordered pairs. Okay. Now, This is a function. Each input has exactly one output, but let's consider what the domain is. The domain would be all of the inputs, and I'm going to put them in order from smallest to largest. So there's your domain. And the range would be, let's see, -11, -6, -1, and 3. Oops. So the domain is the inputs or the X values. The range is the outputs or the Y values. All right. Take a look at this situation. Hang on here. Let's see. We've got 10, 20, and 30. And over here, 20, 40, and 60. And 10 goes to 20, 20 goes to 40, and 30 goes to 60. In situations like this, the thing on the left is considered the input or the domain, and the thing on the right is considered the output or the range. It says, determine whether this defines Y as a function of X. If it does not, find two ordered pairs where more than one Y value corresponds to a single value of X. So this is, yes, this is a function. Each input goes to exactly one output. But let's contrast that with this situation. Let's see, 6, 8, 10, 12, -4 goes to 6, -2 goes to 8, 0 goes to 10, and 0 goes to 12. So this is not a function. Why not? Because 0 goes to 10 and 0 goes to 12. So you have one input with more than one output, not a function, okay? It still is a relation, but it's not a function. Okay, how about this situation? Uh, 10, 0, 13, and 1, 16. Is this a function? Yes, it is. Each input is only going to one output. How about this one? Okay. No, this is not a function because -3 goes to 8 and -3 goes to 12. So you've got an input going to more than one output. It's like a person having two birthdays, so that's not a function. How about this situation? Is that a function? Yes, you can have 4 different inputs going to the same output. It'd be like quadruplets, 4 people with the same birthday. So yes, that's a function. What about this one? Let's see, -4, -1, 0, 2, -1, 6, 0, -3, 4, and 2. This is not a function because you've got x -1 going to 0 and x -1 going to 2. Okay? So if it's a function, each input has to go to exactly one output, but you can have more than one input going to the same output. All right. Now, let's say we had the following equation. Y equals 3x minus 5. And we're going to make a table of values, okay? And let's see, we'll go -1, 0, 1, 2, and 3, okay? So how would we complete this table? Well, if x is -1, that would go right here, and we'd have y equals 3 times -1 minus 5, which is -3 minus 5, or -8. If x is 0, we'd have y equals 3 times 0 minus 5, which is 0 minus 5 or negative 5. If x is 1, we'd have 3 times 1 minus 5, which is 3 minus 5 or negative 2. If x is 2, we'd have 3 times 2 minus 5 or 6 minus 5 or 1. And finally, if x is 3, we'd have 3 times 3 minus 5, which is 9 minus 5, which is 4. Okay. Now, when something is not only an equation, but it is also a function, we have special notation that we use in the place of y. One of the typical symbols we use is this. It looks like an italicized F and then an X in parentheses. Now, that is a single symbol. Even though typically we think something next to something with parentheses is multiplication, it's not F times X, okay? The way we would say this is we would say F is a function of X, or shortening that, we'd say F of X. Well, that causes another problem because of often means multiplication, like in what is 3% of 12. So this thing looks like multiplication and it sounds like multiplication, but it's neither. It's a single symbol, F of X. It's a function notation way of writing y. So how would we take this equation and write it as a function? We'd say F of X equals 3x minus 5, okay? Now, how do we find ordered pairs using function notation? Well, comparing with this over here, we would say F of negative 1 equals. And how would we find that? The same way we did over here. We'd put negative 1 in the place of X, so we'd have 3 times negative 1 minus 5, which is negative 8. So we would say F of negative 1 equals negative 8. This function notation corresponds to this ordered pair in a table, corresponds to this ordered pair written just as a simple ordered pair, okay? So then we'd have F of 0, which would be 3 times 0 minus 5, which is negative 5. So F of 0 equals negative 5. That corresponds to this, et cetera, et cetera. So in fact, we could say what? F of 1 is negative 2, F of 2 is 1, and F of 3 is 4, just using the calculations we already performed. Okay. So let's take a look at some other examples. Let's take the following. F of X equals 2x minus 3. And let's find F of 3 and F of negative 1. So F of 3, that's like completing the following ordered pair. F of negative 1, that's like completing the following ordered pair. Okay, so F of 3 would be 2 times 3 minus 3, or 6 minus 3, or 3. So F of 3 equals 3. That corresponds to the ordered pair 3, 3, which would correspond to the point on the graph 3, 3. Okay, so then let's go back here and find F of negative 1. That would be 2 times negative 1 minus 3, negative 2 minus 3, negative 5. So F of negative 1 equals negative 5. So we're not doing anything new. We did this back in chapter 3 if you took Math 85 with graphing, but we're using a different notation to represent their ordered pairs. Okay. How about the following? Let's see. G of X equals 5x squared plus 2x plus 2. We are to find G of 2 and G of 3. So to find g of 2, we take 2 and put it every place that x appears on the right side of the equal sign. So 5 times 2 squared plus 2 times 2 plus 2, which is 5 times 4 plus 4 plus 2, which is 20 plus 4 plus 2, which is 26. So g of 2 equals 26. If we were to graph this function, the point 226 would be a point on the graph. G of 3 is equal to 5 times 3 squared plus 2 times 3 plus 2, which is 5 times 9 plus 6 plus 2, which is 45 plus 6 plus 2, which is 51 plus 2, which is 53. So G of 3 equals 53, which would also be represented by the point 353 on the graph. Okay. Let's see. Let's take a look at this example. H of x equals x divided by x squared plus 2. We are to find h of 5 and h of negative 2. So h of 5 would be 5 over 5 squared plus 2, which is 5 over 25 plus 2, which is 5 over 27. So h of 5 equals 5/27. H of negative 2 would be negative 2 over negative 2, the quantity squared plus 2, which is negative 2 over 4 plus 2, which is negative 2 over 6, which could be reduced down to negative 1/3. So h of negative 2 equals negative 1/3. Oh, something I neglected to mention. Let's go way back up here. When I first introduced this whole idea, I mentioned f of x. But just like variables aren't restricted to just x and y, function notation isn't restricted to just f. We can have g of x, h of x, In fact, if this was a business algebra class, a cost function would be c of x, a profit function would be c of x, and a revenue function would be r of x. So again, it's not just restricted to f of x. All right, how about this problem? H of x equals x squared plus x minus 2 over x squared minus 5x. Let's find h of negative 2 and then h of 5. All right. So h of negative 2 would be negative 2 the quantity squared plus negative 2 minus 2 all over negative 2 the quantity squared minus 5 times negative 2. Negative 2 the quantity squared is 4, and then minus 2 would be 0, and negative 2 the quantity squared is 5. Minus 5 times negative 2 is plus 10, so we get 0 divided by 14, which is 0. So h of negative 2 equals 0 for this function. All right. How about h of 5? That would be 5 squared plus 5 minus 2, which is 25 plus 5 minus 2, which is 30 minus 2, which is 28, over 5 squared minus 5 times 5, which is 25 minus 25, which is 0. But 28 divided by 0 is undefined. So h of 5 is undefined. Now, what that tells us is this. The domain of this function, the inputs, the x values, cannot include 5. X cannot equal 5 because if you put 5 in, you don't get something real out. The domain of a function is all of the input values that produce a real output value. So if something you put in makes it the output undefined, then that input is not in the domain. Okay. Let's see here. let's say that g of x equals 2x. Then what would g of w equal? Well, we just put w in the place of x, so it would equal 2w. What would g of w plus 1 equal? Well, then we would put w plus 1 in the place of x. So that would ultimately be what? 2w plus 2. Okay, so g of w plus 1. So basically, in general, we could say g of something equals 2 times something. Whatever goes here, and then produces the final answer. How about this one? G of x equals 2x minus 7. So g of w would be 2w minus 7. G of w plus 1 would be 2 times the quantity w plus 1 minus 7, which is 2w plus 2 minus 7, or 2w minus 5. Okay. Now, suppose we have the following. It says, let f of x equal negative 2x plus 5. For what value of x does function f have the given value? And it says f of x equals 5. So in the previous problems, we were given the input and asked to find the output. Now we're given the output because this is saying that y equals 5. So that's going to go right up here. So now we've got 5 equals negative 2x plus 5. Solve this thing for x. So we'd subtract 5 from both sides. 0 equals negative 2x. Divide both sides by negative 2. 0 equals x. So for what value of x does the function f have a given value? When x is 0. So in other words, f of 0 equals 5. Let's take a look at another one of those. Let's see here. This one says, let f of x equal 3/2 x minus 2. For what value of x does the function have the given value? And it says f of x equals 2/3. So again, they're giving us the y value. We have to find the x value. So that's going to go in the place of f of x, which gives us 2/3 equals 3/2 x minus 2. So to solve for x, tell you what, let's clear the fractions. So we'll multiply both sides by the LCD, which is 6. And let's see here, we've got 12/3 or 4 equals 18/2 or 9x minus 12. Adding 12 to both sides, I get 16 equals 9x. Divide by 9, x equals 16/9. So that means f of, hang on here. F of 16/9 would equal 2/3. So again, these last two problems, they're saying, given the function and telling you the output, the y value, what's the input or the x value to produce that y value? Okay, well, that's all I have for you for today. So for tonight, you're going to do part 1 of section 8.2. And I will be back this afternoon at 1:15 with an office hour. Should you have any questions, I'll see you then.